Hello and welcome to the first chapter in this tutorial series on the gameplay ability system. In this topic, we will learn how to add a gameplay ability system into an Unreal Engine project and also implement something known as the ability system component. This is my first ever video tutorial on YouTube and I'm really excited to get started. First, let's understand how gas works. The gameplay ability system works like a galaxy. The actors in your level involving gas are like individual solar systems. We have something known as an ability system component, or the ASC. This is an actor component granted to an actor that needs to implement features of gas. The ASC for an actor is like a star in a solar system. Everything related to the gameplay ability system for an actor revolves around the ASC, like planets revolving around the sun in a solar system. The ASC holds everything together. The first planet in the solar system is the attribute set. ASC manages the granting of attribute sets and the modification of attributes. Attribute sets are actually classes in Unreal Engine, and generally by game design, attribute sets are used to compartmentalize attributes into different categories. For example, the base attributes and the core attributes in Dota. The hero characters can have core attributes like strength, agility, intelligence, whereas the minions or creeps only have base attributes, that is health, mana, and stamina. The second planet in the solar system is the gameplay effects. The ASC applies, removes, and manages many gameplay effects for an actor. The third planet is the gameplay ability. Not only does ASC take care of granting and revoking abilities for an actor, the ASC also activates, stops, applies cooldowns and costs, and so much more for an ability. Now there's another entity, the gameplay queues. Think of these to be like asteroids that revolve between the planets, effects, and abilities. These entities are responsible for audiovisual effects in your game. So technically, effects can apply gameplay cues to an actor, and gameplay cues can also be added, executed, or removed using a gameplay ability. And finally, in the solar system, in fact, in the entire galaxy of gas, gameplay tags are heavily used. Think of them to be like the light and sound of this galaxy. It is literally how gas understands the universe. It is like the radiation and vibration in this galaxy. Gameplay tags are used to label and identify many things in our universe. In the first section, we'll be adding the gameplay ability system to an Unreal Engine project. This GitHub repository, called GASDocumentation, is one of the best known knowledge bases on the gameplay ability system. We'll keep frequenting this GitHub repo to learn more about the gameplay ability system, its various elements, and how to implement them. In this tutorial, we'll be following 5 simple steps to add gameplay ability system into an Unreal Engine project. The first step is to enable the gameplay abilities plugin. So from the edit menu, choose the plugins option to open the plugins tab. Search for the plugin's gameplay abilities and check the box to enable this plugin. You'll be prompted to restart the Unreal Engine editor, but don't do it just yet. Just simply close your plugins tab. In the second step, we'll create something known as an Asset Manager class in C++. So from the Tools menu, choose the New C++ class option, and from the All Classes section, search for Asset Manager. Notice how I already have something known as a base Asset Manager, and we'll be creating just that. So choose the Asset Manager class and click Next. Provide a name for your Asset Manager class, something like Base Asset Manager. Now in your project's path, we shall add the C++ class into something known as an src folder. So the src folder will contain many crucial C++ source files for your project, like maybe the game mode, the player state, the player controller, and so much more. And this is a great place to have our Asset Manager class. Also make sure to have the class type selected to be public so that your header file will be in the public directory and your C++ file will be stored in your private directory. And go ahead and click on Create Class, and Unreal Engine will create the base Asset Manager class in the src folder in your project. So if your project was a blueprint only project, it will now become a Blueprint and a C++ project. I have provided a link in the description if you want to learn more about an asset manager. And now make sure that you have a C++ classes directory in your Unreal Engine editor's content browser. If you don't, in the content browser's settings, you may have to enable the Show C++ classes option. In your project's root directory, in your Explorer, you should also notice a source folder. This source folder is where you'll have all of your C++ classes. If you don't see the source folder, right-click on the U project file and click on Generate Visual Studio project files. So Unreal Engine will generate the relevant project files and modules and also bind IntelliSense data for your preferred IDE, which in my case is Visual Studio Code. And that's why I have the code workspace file. If you're using Visual Studio, you should see the relevant SLN solutions file or any other solution file for your IDE. Click on the solutions file to open up your Unreal Engine project in your preferred IDE. So in the source folder, notice how you have a folder named after your project, and within this directory, notice that you have a private and a public folder, below which you will have a build.cs file. Open the build.cs file and notice that this file is actually written in C#. You have a class named after your project and its constructor. Within this constructor, you have something known as public dependency module names. And now the third step is to add something known as private dependency module names. So it's nothing but just a string of module names, and these can be found in the GASDocumentation GitHub repo in the setting up a project using gas section. So copy the list of module names from the second point in order to add it to your project's build.cs file. So just duplicate the above line and replace public with private. Go ahead and delete all of these module names and paste the module names from the GASDocumentation README file, which are gameplay abilities, gameplay tags, and gameplay tasks. Go ahead and save your build.cs file, and in the fourth step, we should operate on the base asset manager class that we just created. So notice how in your source and your projects directory, within the public and SRC folder, you have the base asset manager header file. So go ahead and open this base asset manager header file, and notice how this class is quite empty. It is an empty header file. We'll be overriding a method here from this parent asset manager class. So under the protected access specifier, go ahead and override this method, start initial loading. Right-click on the newly declared function name and click on create declaration or definition, which will create the definition in the relevant C++ file. Within this function definition, I'll first call the superclasses method and then include the ability system globals header file. Don't worry about any squiggles or warnings. And now within this function, it is time to call this init global data method, which is part of the ability system globals. So go ahead and copy this method call and paste it in your start initial loading method. So basically this asset manager class should load when I open up the Unreal Engine editor, and when it does, the start initial loading method is invoked. And during the execution of the start initial loading method, this ability system globals init global data method is invoked. But what does this method actually do? This init global data method is required to use something known as ability target data. So ability target data is a particular structure for targeting data, such as a target location or a target actor, or maybe an array of target locations or target actors. And usually these target data hold hit result structures, which contains hit location, hit actor, impact normal, and so on. If this init global data method is not called, and if we use the target data, our game could crash or the clients will be disconnected from the server. We will notice this later further in this tutorial. Fortnite and Paragon use gas, and Fortnite calls it from the asset manager's start initial loading method, which we just did, whereas Paragon called it from the Unreal Engine init method. So the gas documentation advises calling this method in the asset manager's start initial loading method. So this is boilerplate code of gas, and you should call this method in your project to avoid any issues with target data. Now, in order to see if this method is actually executing, I will add a simple log message with the string hello world. So this can help me understand if this asset manager is being used by the Unreal Engine editor and if the start initial loading method has been invoked at all. Now the fifth and the final step involves adding this asset manager into a default engine ini file that can be found in the config folder. So open up the default engine ini file and notice the different sections within this ini file. Scroll down to script/engine.engine. Within this section, go ahead and create a new property called asset manager class name, whose value will be written in this manner: /script/ your project name dot your base asset manager class name. So for me, it reads something like this: /script/ GASDutorial dot base asset manager. So now, by default, whenever your Unreal Engine editor opens up, this base asset manager is loaded, and in the future, we will notice why we need this to use ability target data. Now save all of these files, the build.cs, base asset manager header file, its C++ file, and your default engine ini file. And now it's time to build your C++ files and run your editor. So from the terminal menu, click on Run Build Task and search for Editor Development Build. Select this build task, and now your C++ files are being built. Notice how I have something known as a total execution time in my terminal, meaning this build was a success. It completed all of the 21 tasks. So make sure your project builds successfully and you get this total execution time. And now you can open up your Unreal Engine editor, but I like to open the editor in debug mode. So in VS Code, in the Run menu, choose Start Debugging. It will use the same build task, Editor Development Build, and it will launch the editor in debug mode. Notice how you may also have a stop and a pause button to stop and pause the execution of this Unreal Engine editor program. And now in your Unreal Engine editor, in the output log, scroll up and try to locate your Hello World log message. Notice that I have my Hello World log message, meaning my base asset manager class was properly loaded. And so these are the 5 steps that you need to follow to add the gameplay ability system into your project. And this concludes adding the gameplay ability system to your existing or a new Unreal Engine project. In the second step, we'll be implementing something known as the ability system component. As per the GAS documentation project, the ASC is the heart of GAS. It is technically an actor component, which handles all of the interactions within the ability system. So any actor that wishes to use gameplay abilities, have attributes, or receive gameplay effects must have an ASC attached to them. So as a developer, you could even subclass from this actor component and extend its capabilities based on your game. So as I'd mentioned earlier, the ASC is like the sun of the solar system of an actor. The abilities, effects, cues, and other elements of an ability system revolve around the ASC. I have created 3 character classes for my game. These classes are created in C++ because the ASC has to be granted and configured in C++. So if you have a blueprint character in your existing project, you will have to reparent it to a C++ character class. So the first class that I have here is the base character. This is subclassed from the character class itself in my public spawn folder. This is the folder where I'll have all the relevant characters and pawns in my game. In the same folder, I've created 2 of its child classes, the hero and the minion, just like maybe in Dota or League of Legends. I have also created my own player state in the src and game folder. So go ahead and create these 4 C++ classes, the base character, the hero, the minion, in the pawn folder, in your C++ public directory, and a player state known as the base player state in your public's src folder's game folder. After the creation of your C++ classes, open the project in your preferred IDE. In your public and pawn folder, open up the minion.header file. So now it's time to grant the ASC, and we shall start with the minion class. This is where I'll have to declare and define certain properties and methods pertaining to the ability system component. But since the minion subclass is from the base character class, I shall declare and define these methods and properties in the base character class. So open your base character class in the same folder. You may have some starting methods like begin play, tick, and setup player input component. So in order to grant the ASC, first we must include certain header files. I'll first include the ability system component header file, then the ability system blueprint header file, and then something known as ability system interface. So technically, any actor implementing the ASC must implement this ability system interface. So specify that interface in your base character class in order to implement it. Now, after all the method declarations, I'll create a section known as Ability System Component. And in here, I will create all of the relevant properties and methods of the AC. Under a properties subsection and in the protected access specifier, I will create an object pointer to the Ability System Component. And in the method section, we have to implement a certain interface method. So go over to where you have specified this Ability System interface, right-click, and click on Go to Definition. Visual Studio Code will take me to this Ability System interface header file. You can see how this interface has been declared, that you cannot implement this interface in blueprints. This is why we had to create C++ classes for our characters. So we need to implement this method getAbilitySystemComponent, which returns the object pointer of the Ability System Component. So just copy that line, and in the method section under a public access specifier, paste that method declaration. So this is nothing but the getter method for the AC of this actor. That means we should be returning this Ability System Component property. So usually I like to implement and define getter methods within the header file, and so I have returned this Ability System Component. So this is the first part of granting the AC. The second part of granting the AC is to construct it in your actor. Under a public access specifier, declare its constructor. Create the definition of this constructor. Now in the definition of the constructor, you will have to create the AC. That is done using the createDefaultSubObject method. For its template parameter, I shall pass the uAbilitySystemComponent class name. The parameter requires the name of the subobject, for which I shall pass the text AbilitySystemComponent. So now this method returns a templatized version of that actor component, which we shall reference it with the AbilitySystemComponent variable that we had created in the base character class. And this is pretty much it, really. This is how you actually grant the AC to any actor. But we shall be doing another third part of this granting of the AC, that is replication. So we can set this AC to replicate using its actor component method, setIsReplicated, and we shall just specify the parameter value to be true. So now the AC of this actor is replicated to all machines in a multiplayer network. But it doesn't end there. We need to call the AC's method setReplicationMode. So there are about 3 replication modes to an AC, the full, the mixed, and the minimal, and its details have been provided in the GASDocumentation project. The minimal is used for AI-controlled actors, where gameplay effects are not replicated to anybody. Only the gameplay tags and gameplay cues are replicated. Whereas in the mixed replication mode, it is only applied for player-controlled actors, where gameplay effects are only replicated to the owning client. So this pretty much is the only difference between mixed and minimal, and we should be using the replication mode minimal for minion. So the replication modes are specified in this gameplay effect replication mode enumeration. You can use its scope resolution operator and access all of the 3 enumeration values, and I shall use minimal. And you can read its description. Gameplay effects are not really replicated, but only the gameplay cues and the gameplay tags. So this completes the granting of the AC for the minion. So now what about the hero? Well, its AC will not be granted in its constructor, but rather in the player state. So open up your newly created player state class, and this is where we shall grant the AC. So as with the base character class, we should just declare these properties and methods in the base player state, and also implement the ability system interface and include the relevant header files. So I've just copy-pasted the same set of operations into this base player state class. I have declared its constructor, and in here we'll be granting the AC in the same way that we did for the minion class. So from your minion's constructor, copy these lines and paste them into your base player state's constructor. But you'll notice that the replication mode is still minimal. You may change that to mixed. So this time, the gameplay effect is only replicated to the owning client, that is the autonomous proxy, from the server, and not to the other clients or the simulated proxies. Only the gameplay tags and gameplay cues are replicated to all clients. So this is how GAS ensures efficiency across a multiplayer network. And finally, you can also set something known as the net update frequency for this class. I shall set the net update frequency to about 30, and you can learn more about the net update frequency from the link I've provided in the description below. So this number is nothing but the number of times in a second this actor will send an update about itself. And GASDocumentation suggests that if your ASC is on the player state, you will need to increase the net update frequency of your player state. So lower values will lead to delays or perceived lags in changes to attributes and gameplay tags. So in fact, you can set this to a very high value of maybe 100. So now every second, this base player state will keep sending updates 100 times. So now we have granted the ability system component to our base player state. But why are we doing it this way? Well, these hero player characters are quite special. They can die and respawn, and also transition levels. Not only should their information be accurate across the network, we will also need persistence of their state and information during these respawns and level transitions. And this is where we will need the player state. The player state class can be a great place to store information on the player character. The player state is replicated across the network to all clients. Also, the server always being the truth, the player state's information is always accurately replicated by the server to the clients. And this information cannot be easily modified by any client. So how does GAS manage that? The ASC actually has references to two actors, the owner actor and the avatar actor. The actor it is attached to is known as the owner actor, whereas the physical representation of the actor is known as the avatar actor. So technically the actor that you see in the level is always the avatar actor, but the owner actor need not be the same as the avatar actor. Both the owner actor and the avatar actor can be the same actor, for example in a minion, in a much simpler actor, but usually in a player's hero character, they will be different actors. So having created the ASC in the player state, the information and state of the player hero character, like attributes or gameplay effects that should be persistent across spawns and across levels, is replicated, accurate, and protected from any modification by any client. Now that we learned the difference between the owner actor and the avatar actor, and why the owner actor of the hero player is best made to be the player state, this brings me to the third step, initializing these owner and avatar actors of the ASC. Let's start with the minion class. Under the protected access specifier, declare and override its beginPlay method. In the beginPlay's definition, first call the superclasses method and then validate the ASC. That is, if the ability system component is a valid pointer, call the ability systems method init ability actor info. This requires two parameters, the owner actor object pointer and the avatar actor object pointer. For the owner actor, I shall provide this object pointer, and even for the avatar actor. So that's all there is to it really. To initialize the actors of the ASC, you should just pass in the object pointers of the owner actor and the avatar actor to the init ability actor function. As for the hero class, first I would like to forward declare the base player state class, and then I shall override two methods, the onReplicated player state and the possessBy method, which takes in for its input parameter a controller object pointer. Technically, onReplicated player state is called when this player state replicates in the client, and so is a client-only function, whereas the possessBy method is called on the server when the server understands the possession of the spawn. So this ensures that whenever your character is possessed by any player controller, the ability actor info of the ASC is initialized. So we're going to initialize the actor info in both these methods, so that whenever the player state is replicated, or when the controller is possessed upon, the actor info of the ASC is always initialized. Now in my C++ class, I shall include the base player state header file. In the definition of the onReplicated player state, I shall call the superclasses method and attempt to get the base player state using a local variable and using the getPlayerState method of this character class. This requires a template parameter within which I can pass the base player state class name, and that is it. That is how I get the player state of this character class. Now in an if block of code, I shall first validate my player state. I shall refer the player state's ability system component with our ASC variable. So I will use the ability system component variable of this base character class and assign it to the player state's ASC by using its interface method getAbilitySystemComponent that it implements. And so now I can call this ability system component's init ability actor info method, and for the owner actor I can pass in the player state, and this object pointer for the avatar actor, and that is it. This time around, it's all about using the player state's object pointer for the owner actor, which is fetched using the getPlayerState method. And now in the possessBy's definition, I'll first call the superclasses method. I shall copy the same lines of code from the onReplicated player state method and paste them into my possessBy method. And so now Whenever this character is possessed by a controller, this method will be called, potentially allowing another player state to be the owner of another player's hero character. Kind of like in Dota, where if a player disconnects, you can actually possess their hero and control that hero. Now in my project, I have created a base player controller C++ class in the src and game folder alongside the base player state. This is nothing but the child class of the player controller class, and this will be the third class where we have to initialize the ability actor info. So regardless of where your movement and look functionalities have been implemented, you may want to create a new player controller C++ class. So go ahead and create a new base player controller C++ class. So in my editor, I shall open up the header file of the base player controller in the src game folder. You will only have to override this method, onPossess, which takes in an input parameter, a pawn object pointer. In my base player controller C++ class, in the onPossess definition, I'm doing the same functionalities as I did in the base character. I'm calling the same method getPlayerState, but this belongs to the controller class and is a template method that returns the object pointer of the player state. So if the player state is a valid pointer, I shall get the player state's ability system component and call its initAbilityActorInfo method. Obviously the owner actor will be the player state and the avatar actor will be this inPawn method parameter, which is actually the newly possessed pawn. And so this concludes our third step in initializing the ability actor info of the ASC. So the initialization was only required in 3 classes: the minion, the base character, and the player controller. So you may now build and compile your code and launch your Unreal Engine editor. So in my editor, in the content directory, I have created a base folder. Base is where I will be storing all of this project's files. I have 3 folders: assets, pawn, and src. Let me first show you the src folder. In this, I have a game folder within which I have the game mode and the blueprint base player controller. This blueprint base player controller is nothing but the child of my C++ base player controller class, and this is where I will be invoking abilities in the future topics. I have already bound the character's movement and look in the base player controller C++ class. In the pawn folder, I have implemented the blueprint hero class, that is a child of my hero C++ class. This is what the blueprint hero looks like. For its mesh, it uses the SK mannequin that was part of Unreal Engine 4, and for the animations, it uses my newly created anim blueprint class. But this anim blueprint is nothing but the copy of anim blueprint mani that comes with Unreal Engine 5, and I have copied that into my assets and animations folder. And as you can notice, I have not even replaced the skeleton to Unreal Engine 4. It just works.
All of this just works.
And so after setting up the mesh and the animation blueprint, there was nothing else. So now my game implements a blueprint base game mode, and within this game mode, I have set the default pawn class to be my blueprint hero and the player controller class to be my blueprint base player controller. I have also configured the player state to be the base player state. And now I'm ready to play the level. And my possessed pawn is the blueprint hero, which is not the Unreal Engine 5 mannequin, but the Unreal Engine 4 mannequin. I'm able to move and look because I've bound their inputs in my base player controller C++ class. So in order to know if your ability system has been granted, just press the tilde key and type the console command show debug ability system. And this will show the debug information of this pawn's ASC. Notice how the avatar actor is a blueprint hero and the owner actor is a base player state. You can also see the controller and the possessed pawn. So in the next topic, we will be seeing attributes in this debug information. Attributes such as health, stamina, mana, strength, agility, intelligence, and so on. So this concludes the topic on adding the gameplay ability system and implementing the ability system component. Let me summarize the steps we have performed. In the first step, we added the gameplay ability system to our project. This was a small 5-step process. Firstly, we enabled the gameplay ability system plugin in the Unreal Engine editor. Secondly, we created an asset manager class in C++. So the creation of this class will turn your project into a Blueprint and C++ class. And so we opened our project in C++, and in the source folder, and in your project folder, and in the project's build.cs file, we included the private dependency module names, the gameplay abilities, the gameplay tags, and the gameplay tasks. In the Asset Manager start initial loading method, we called the init global data method from the ability system globals class. We also logged a message, hello world, to see if this method has executed. And this can be verified in the output log in your Unreal Engine editor. So you may scroll up and find your log message, hello world. If you see this, then your Asset Manager was loaded successfully. And the fifth and the final step involved adding the Asset Manager class name into our config's default engine ini file. In the script/engine.engine section, for the property Asset Manager class name, we use the value /script/project name dot Asset Manager class name. And that was a 5-step process to add the gameplay ability system to an Unreal Engine project. The second section of this topic involved implementing the ability system component. It involved learning the theory of the ability system component. It is an actor component that handles the interactions of various elements of the ability system, like gameplay abilities, attributes, gameplay effects, and so on. So like I had mentioned, it is like the sun of a solar system that holds everything together. It coordinates and manages all these essential elements of the ability system. We created the C++ classes base character, hero, and minion in the C++ directory spawn folder, and the hero and the minion being the child classes of the base character class. And we created our very own player state class in the src's game folder. The base character implemented the interface ability system interface. We defined a variable that is the object pointer of the ability system component, and we implemented the only method of the ability system interface, the getAbilitySystem component, which returns the object pointer of the ability system component granted to this base character. For the minion character, the ability system component was granted in its constructor by using the simple createDefaultSubObject method. The ASC was also set to replicate, and for the minion class, the ASC's replication mode was set to minimal. As for the player's hero character, we did not grant the ASC in the hero class, but rather in the player state. So in the newly created base player state class, we implemented the ability system interface and defined the same properties and methods as was done in the base character class. And so in the constructor of the base player state, this is where we granted the ability system component. The ASC has been set to replicate, and the replication mode is set to mixed, where gameplay effects are replicated only to the owning client, whereas the gameplay tags and gameplay cues are replicated to all clients. So this is the major difference between mixed and minimal, where in minimal, gameplay effects are never replicated to anyone. You may not even have to set the replication mode to full in single-player games. And optionally, you can set a value to the net update frequency to a pretty high value for the player state. So the player state updates itself these many times a second. And finally, in this section, we learned about the owner actor and the avatar actor. We learned that the avatar actor is a physical representation actor in the level, and the owner and the avatar actors can be the same for the minion class. Whereas for a player character, the avatar actor is always a character in the level, whereas the owner actor is the player state. So whenever player characters die and respawn, and also transition levels, not only should their information be accurate across the network, we will need persistence of their state and information. The player state is replicated across the network to all clients, and the player state's information is always accurately replicated by the server to the clients. And no client can modify this information because the server is always the truth. So the player character's attributes and gameplay effects are accurate, protected, and replicated efficiently. The third and the final step involved initializing the actors of the ASC. This was done using the ability system component's initAbilityActorInfo method, and it was done in 3 classes. Firstly, in the minion class, which takes in 2 parameters, the owner actor and the avatar actor object pointers. We first called this method in the minion's beginPlay method, and we passed the minion object pointer to both the owner and avatar parameters. The second class was the base character class, where we called this method in the onReplicated player state and possessed by method. We pass the player state into the owner actor and this object pointer into the avatar, and this was done in both the methods. And the third and the final class was my own C++ player controller class. This method was called in my base player controller's onPossess method, where I pass the player state as the owner and the reference of the newly possessed pawn as the avatar actor. So yes, this had to be done in 4 methods across 3 classes, and this is part of the GAS boilerplate, but it is a one-time operation and can really be helpful. So now it was time to see the output. In my content folder, I'd created a new base folder, where I will store all of the essential classes pertaining to my game. I have created 3 folders, assets, spawn, and src. Within my assets folder, I have the animations folder, within which I have the animation blueprint of my character. This is nothing but the copy of the animation blueprint that comes with Unreal Engine 5's Manny. In my pawn folder, I have the blueprint class of my hero. There is nothing much to this character. It just implements the Unreal Engine 4 mannequin and that newly created animation blueprint. And finally, in the src folder, I have a game folder, within which I have the blueprint child of my base player controller C++ class, which is where I will be invoking all of the abilities, and the blueprint base game mode, which is what this level will use. The game mode's default pawn class will be the blueprint hero. The player controller class will be my blueprint base player controller, and the player state class will be the base player state. Now if I play my level, I will notice my blueprint hero instead of the Unreal Engine 5 mannequin. I have configured the move and look in the base player controller, and when I run the console command show debug ability system, I can see the debug information of this character. You will notice that the avatar actor is the blueprint hero itself, but the owner actor is the base player state. We will also see attribute values of this character in the next topic. So I hope this video was useful. Comment down any queries you have or what you felt about this topic. Thank you for watching and happy learning.